Let me show you how to review the topography data captured by the TopCon Maya. First, navigate to the measurement screen. This can be done in one of two ways. Immediately after capturing topography data on a patient, you can navigate from the capture screen to view the data by selecting the Measurements tab. Or you can save and open previously captured data from the home screen. Select List, locate and select the patient and the exam you want to review. Then touch Open to reach the measurements, which open at the Topography Map tab by default. Select OD to view the right eye, or OS for the left eye. Alternatively, you can review topography maps for the two eyes side by selecting the OD-OS tab. The map scale can be changed between absolute and normalized. An absolute scale helps you see at a glance how typical or atypical the anterior corneal curvature is. The color scale is standardized, making it possible to compare between one visit to the next. Shades of green indicate a typical curvature, blues indicate a flatter curvature, and warmer colors indicate a steeper curvature. A normal cornea is likely to have only 3 or 4 different colors within the pupil area. A normalized scale uses the full color range to describe that particular cornea, resulting in much smaller step sizes and more detail as a result. The map section in the lower right allows you to choose between an axial or tangential topography map. Axial maps could be thought of as providing a general view of the anterior corneal shape. The corneal curvature is described in relation to the optical axis, resulting in a smoother map. For example, this is useful to support contact lens fitting. Tangential maps provide local curvature information about individual areas of the cornea and are therefore better at describing the peripheral corneal shape and irregularity. Topography maps can be viewed in a number of different ways. Maps provide the classic two-dimensional map. 3D provides a three-dimensional view, which can be useful for patient education. And Profile, or PROF for short, displays the curvature profile for each principal meridian along with the difference between the meridians. This can be useful for examining the risk of corneal lens decentration based on the corneal profile. The buttons above the topography map provide different indices derived from the topography data. The K tab displays simulated keratometry values for the principal meridians over a 3 mm zone, along with the eccentricity value for each meridian and the amount of anterior corneal astigmatism. SimK have their steep and flat axis exactly 90 degrees apart. Alternatively, you can choose to display keratometry values over zones of 3, 5, and 7 mm, or 2, 4, and 6 mm. You can change this in the settings menu. The I tab displays indices describing the anterior corneal surface. Astigmatism quantifies the astigmatism over both the central zone and a larger zone. This is important to consider for corneal contact lens fitting. APP, or average pupillary power, provides a single value for the corneal power over the central 4.5 mm zone. Asphericity is a measure of how the anterior corneal shape differs from a spherical cornea. You can select your preferred form for expressing asphericity in the settings menu and access a detailed description if needed. The amount of longitudinal spherical aberration provided by the anterior cornea is expressed in diopters. This compares the central corneal zone with the cornea 8 mm from the apex. This also quantifies how more or less powerful the corneal periphery is compared to the central cornea. Curvature irregularity is an expression of the irregularity of corneal curvature expressed as a standard deviation over a 4.5 mm area. The surface asymmetry index quantifies how the flattest and steepest halves of the cornea differ over the central 4.5 millimeter zone. The AK, or apical keratometry tab, provides indices related to two options to screen for keratoconus. We'll start with KC. AK quantifies the power of the cornea at its apex. AGC, or apical gradient of curvature, displays the average rate of change of curvature away from the apex. SI, or symmetry index, compares the average curvature of two matched zones in the superior and inferior cornea. KPI, or keratoconus probability index, is calculated from the previous three indices and states a percentage likelihood that the cornea has keratoconus. For a patient with a high likelihood of keratoconus, further metrics are provided, describing the cone area, diameter, location, and circularity. Consult your MYAH user manual if you want to know more. An alternative keratoconus screening algorithm is the CLMI, or Cone Location and Magnitude Index. This is described in the user manual and in the peer-reviewed paper by the Collaborative Longitudinal Evaluation of Keratoconus, or CLEK study group. The next tab along the top is P for pupil. It displays the outline of the pupil over the topography map so that the area of the cornea relevant to visual quality can be seen. This data will relate to the pupil size obtained during topography unless additional pupillometry has been captured, in which case the red line indicates the photopic pupil and the blue line the mesopic pupil. Pupil size and decentration from the optical axis are also displayed. Additional metrics in this tab include the corneal diameter, in other words, the horizontal width of the cornea in millimeters, KC, or the central corneal curvature in diopters, the APP, or average pupillary power, which quantifies the corneal power over both 3 millimeter and 4.5 millimeter zones. And that's an overview of the topography analysis that's provided by the MYAH.